This is the second part of high-level functions, specifically aimed at explaining how xlsread works. After a brief review of DLM-read, which is the other high-level function that we've seen, we'll see how Excel works. In order to understand Excel, we'll be introduced to the idea that a function can return more than one value, which is also the case for min and max. A brief review of DLM-read first. DLM-read only works if the data file is not Excel, all numerical data separated by a unique delimiter. For example, we had a file that had 2 columns of decimal numbers, and we were able to upload it so we could plot it and make it look like an airfoil. The command was very simple, a variable equal DLM-read with the name of the file in quote because it was a string. But imagine the data all of a sudden is in an Excel sheet. In that case, we can no longer use DLM-read, but will the overall idea of the problem change? No. So really we only have to work on one command. Instead of DLM-read, what command will it be? There is a very practical command in MATLAB, which is xlsread. XLS for Excel and read to read data from Excel. So luckily enough, we don't have to change too much to this code. xlsread, and similarly we have a string, the name of the file. This will do the exact same code and produce the airfoil plot. The basic syntax for Excel is num equals. As an argument you have the file name, but it is possible to have 2 arguments. The second one being as a string, again, the sheet's name. For example, if we wanted to access sheet 2, we would write sheet 2 as a string. The default is obviously sheet 1. If you go online and Google spreadsheet, you'll usually find text included with the numbers, either as the heading of each column or description, legends, anything. Excel is not limited to numbers only. On a very simple example like this one, where we have 3 columns, name, age, and grade, how is MATLAB going to handle it? Let's try to code it. Let's imagine data equal xls read, and then as a string, the name of the file. You'll notice first of all that it's very similar to DLM-read. If you look in the current folder, we do not have our Excel sheet. MATLAB will not go hunt in your entire computer to find your file, so it's important to change our directory. In my case, the grades.xlsx spreadsheet is in a specific path on my machine, 10, 10E, and so on. I must change MATLAB, so this is the button right here, the one little folder that has a green arrow pointing down. When you click on it, it allows you to browse to go find your folder. So mine is in 10E. Now you'll notice nothing shows up here, because by default we're trying to open it using MATLAB. Excel is not recognized, so nothing shows up, but this is the folder that you want to be in. If you notice the top, it matches exactly where I want it to be. By hitting select folder, you'll notice that everything gets updated on the left. The current folder now has my very specific file, grades.xlsx, so I can officially call back my function. You may notice that it takes a little bit of time. While it is a very powerful function, Excel does have to be taken into account. You can also notice that it is not case sensitive. Grades here was a capital letter. However, grades here is a lowercase. Now, in the workspace we can see our data. Let's take away the semicolon. If you remember our Excel sheet, it had a title, it had a column full of names. So what happened to it? Obviously, the xlsread function does not automatically grab everything. We have to understand that xlsread filters. MATLAB will filter automatically the numbers first. If you think about it, MATLAB is a calculator, so it's normal that the numbers are by default. But, of course, MATLAB does import everything. xlsread actually returns 3 values. In order they are: the numerical values first, which is what we have right now. Second, the string values only. And third, the entire Excel content as it was, without any filtering. So the general syntax is now open bracket, but the square brackets, num, comma, text, comma, raw, brackets. If you look at the documentation, this is how it will be presented to you. Though we are using square brackets, it has nothing to do with vectors. This is the notation that we have to use to collect more than one return value. But we are creating 3 separate variables. For example, in this spreadsheet, the way we currently called it, we collected only one value back, so I only have one variable. So MATLAB again loves numbers. That's the first thing it will return. If I also wanted the strings, then I would have to move up one level. I want to collect 2 return values. So I all of a sudden have 2 variables on the left side of my equal sign. If I wanted the entire thing without anything modified, then I would also go up one level by saying I want the raw data. Notice again the use of the brackets. The data types in each of the arrays are very specific. The first one, the first value returned, is numerical. So in this case, it's a 6x2 matrix of double. My text and raw are strings, which is why we had to introduce cell arrays. My text is a cell array of characters. And notice we are still rectangular. MATLAB filled in wherever there was number by just blanks. The raw data is everything combined. Remember that this is again a cell array. So in every container there is something completely different, which is why we are allowed to mix the strings with the numbers. The order of the return value is very specific. While your variable names don't matter, the order in which we write them is very crucial. In this case, I by mistake flipped the first 2 variables. My text is first, Asian grade is second. And the third one, I even called it randomly blah. That doesn't make a difference to how the values are returned. The first return value will be the number. I, as a programmer, picked to have it called my text, but that will make absolutely no difference. My text will have the numerical values. As far as a programmer's point of view, this is the worst variable name you could do. It doesn't represent text. Age grade is the second variable, so it will contain the second return value. And that's the strings. Again, worst variable name ever. Last but not least, blah, which really doesn't help us figure out what's inside, will contain the raw data. So be careful of that order. Think about programming. If you don't need the string and the raw data, don't collect it. It will use memory. If you don't need it, then don't collect it. No one is forcing you to collect the second and third return values. The opposite is somewhat untrue. If you need the raw data, and only the raw data, there is no way to skip over part 1 and part 2. So, since 2009b, we can use the tilde to ignore the return values, but they must be written, and even better, the commas have to be there. We don't want the first return value, we don't want the second return value, but we want the third return value. While you could write num in my text, again, you'd be wasting memory, so might as well not collect them. If there happens to be holes in the spreadsheet, MATLAB fills it with the NaN value. So if you look at your workspace and double click on your variables, you'll actually see NaN written inside your variables. There is a function called isNaN that can help us filter out those numbers.